Alright guys, I want to use this lesson 4.2, this homework, to talk about a recursive formula for sequences, okay? So when we talk about the recursive formula, it's spelled R-E-C-U-R-S-I-V-E. So the recursive formula sounds like it's another formula that you have to memorize, but what's really nice about it is it's something that you guys do naturally. And that's what I'm going to get ready and go through and show you, the recursive formula for arithmetic and geometric sequences. So the first thing we need to do, like in problem number 1, is we need to identify which sequence it is. Okay. So when I look at this, if I'm trying to go from 4 to 8, and then from 8 to 12, and then from 12 to 16, it looks like all I'm doing in this is I'm just going to be adding 4. Okay. So that means this is definitely an arithmetic sequence. It has a common difference, so no common ratio, and the common difference in this case is 4. Okay. So now the recursive formula, when we talk about arithmetic sequences, is what we just do naturally when we're analyzing sequences. Okay. And the way I look at it is when I see this word re in front of it, it reminds me of like having to rewind a videotape or rewind a cassette back in the day, you know. So I need to know, when I do use the recursive formula, I need to know the term before the one that I'm trying to find. So for example, when I look at 4, 8, 12, and 16, I know that the 4 is my first term, the 8 is my second term, third, and fourth term. So the recursive formula for an arithmetic sequence is, you would write it like this. It's AN equals, and it would be AN minus 1 plus that D, which is the common difference. And this looks really complicated, but it's really not. So the recursive formula just means I need to know the term before the term that I'm trying to find. So if I want the 5th term, I have to know the 4th term. So in this case, I would say A5, I want the 5th term, I need to know the 4th term, and then I'm going to add my common difference to it. So in this case, if I want the 5th term, all I'm going to do is just take 16 and I'm going to add 4 to it to get 20. So I know that the 5th term in this case, which is the next term in the sequence, is going to be 20. And that's all the recursive formula is. And it works the same way when we talk about a geometric sequence. Okay? So we're going to look down here at problem number 3. So if I'm trying to get from 3 to 12, I know I have to multiply that by 4. 12 to 48, again, multiply it by 4, and so on. Okay? So when I look at this, I know it's going to be a common ratio. So let's get rid of that difference. I know I'm multiplying it by 4. And in this problem, they are giving me the first term, second term, third term, and fourth term. So let's use this recursive formula, and we're going to use it for a geometric sequence now. Okay? So the way I would write it is very similar to the arithmetic one. Is I'm going to say g of n, so this is the term I want to find, and the recursive formula is it's the right? So I need to rewind. I need to know the term before the one I'm looking for. So we would say that this is g n minus 1, and then because it's a geometric sequence, I definitely need to multiply this by just the common ratio. I'm just going up 1, right? So I need to know the term before it. So the way we would do this is we know the common ratio is 4. If I'm looking for the 5th term, then I would just say g5 equals, well, this would be g of 4 times r. So to substitute all of our numbers in, I'm going to say g of 5 is going to equal this 192, and I need to multiply it by 4. So you'll break out your calculator. We'll take 192 times 4 equals 768. So I know the 5th term is 768. And that's all the recursive formula is. It definitely sounds like it's more than it is, but really you just need to know the term before it, and then you either add for arithmetic or you're going to multiply for geometric just to get to that next term.